Hey scholars, welcome to Gear 3. So as you can see in the title there, Gear 3 is going to focus on simulation of experimental data. All right. In experiments, you typically do a lot of comparison of groups, right? So we're going to just kind of set up a mock, a simple mock experiment. And then sort of, simulate some numbers that we would see for, this group, the control group versus the treatment group and things like that. And then, show you how to run that in SAS. And then, like we've talked about for Chapter 8 and, in the lecture slides for Chapter 9, just walk you through the process of analyzing experimental data and show you how to write it up. Okay, so just to kind of give you a feel for how to do this. Okay, all right, let's go. All right, so the objectives: conducting statistical analysis of simulated experimental data, conducting hypothesis tests based on that experimental data using SAS, and then creating a short, very short slide presentation of the results. Okay. All right. All right. So some of the key terms here you've seen already, and we've talked about them in the lecture for Chapter 9. All right. The one thing you haven't seen, though, is this concept right here. All right, nested do loops. All right, so this has nothing to do with experimental data, experimental research. Okay, but since we're running a simulation of experimental data, nested do loops are a really nice way to kind of efficiently write a program where you want to create that type of data. Okay, so we'll talk quite a bit about that just to make sure you understand exactly what's going on. Okay, all right, but everything else is pretty straightforward. All right. Here with research question. All right, you'll kind of see what that is in just a few minutes, but it's exactly as it sounds. All right, it's a question that you have that you want to do research on. Okay, so we'll talk about a research question, and what I want you to do is to set up a research question. Really simple one. You can use the one that I give you here. All right. As a matter of fact, if you want, you can copy all the slides. But again, I always encourage you to kind of go off on your own. All right. So maybe use what I present here to you as some sort of foundation for you to maybe, venture out and try some things yourself. Okay. All right. So try to think of an experiment or try to think of a research question first, and then try to think about how that would play out in an experimental design. All right, and again, you're just going to kind of keep it simple if you decide to do that. And again, since and to encourage you to do that, as always, I'm not going to nail you on your grade if it's a complete mess. All right. The important thing here at this point in your development is for you to try. Okay. Try to sort of reach out beyond and extrapolate. All right. Extrapolate from the information you've been given. Okay. Just to again venture out. Okay. All right. So there we have several tasks. All right. So first of all, think about a research question and then write a brief explanation of the research question. And again, I'm going to show you an example of what that might look like. Okay. And then think of two variables for an experimental study of the research question. Okay. And you want to define each variable. And again, you don't have to go into a lot of detail in the definition. I'm not expecting that from you right now, right? You will have to do a great deal of work defining each variable for your research when you get into your research methods courses, right? You're really going to get hammered on, definitions of, variables and things like that. Okay, but here, we're focused just on the stats side of it, so we're not going to worry too much about the, giving, these really in-depth definitions of things. Okay. All right, and then from there, we want to, write a brief description of the experiment. Okay, and that includes, the comparisons we're going to make. Okay. Let's see, and then we're going to set up a data set, SAS data set that simulates data from a completely randomized experimental study. Now, this is like the simplest setup for, or simplest design for an experimental study. Okay, so hopefully, you'll be able to follow along pretty well. All right, but again, it's kind of straightforward. All right, and it's probably stuff you've already been exposed to at some point. All right, let's see. All right, the next thing we're going to do, conduct t-test, right? And so we're going to compare groups, and we're going to make 3 comparisons of the experimental groups, and we'll talk about what exactly those groups are. We'll identify those groups. All right, in the slides. Okay. All right, and then we're going to report the results of each test, interpret the results. All right, and then at the end of this, right, I want you to submit a copy of your SAS program, your written results in APA format. So, and again, you'll see what that looks like, and we cover it, writing up results in APA format in Chapter 8 and in Chapter 9 lectures. Okay. But again, if you need some help with that, please just contact me. All right. And then you also want to include a written interpretation of the results. So you're going to get the results, and you're going to say, all right, this is what the results say. All right. And then you're going to, give a quick statement rather, about what the results mean in terms of your hypothesis. Okay. All right, and in terms of your research question. Okay. And then, the Dropbox for Gear 3 isn't set up yet, but after you get all that stuff done, you'll just submit it to the Dropbox for Gear 3. Okay. All right, so here's the research question. Right? Does exposure to social stress reduce risk-taking behavior? All right. Now, and again, that's a pretty abstract, research question. Okay. And a lot of, research questions are abstract. They're not grounded at any particular. They're not necessarily grounded in some particular situation or condition. Okay. All right. But does exposure to social stress reduce risk-taking behavior? All right. And so here's the connection, all right? So, when I was trying to think of this research question and all this, I was trying to think, all right, I want to dive into something that's familiar to them, okay? Something that they see pretty much on a daily basis, something that they've seen many times in their life, okay? All right, so imagine yourself sitting in class, right? The professor asks, some question. Seems like a hard question. All right, the professor asks, for people to respond. All right, so let's hear your responses. All right, what do you think about that, class? Right? Okay. So there's so many times when, students are sitting in the class and they're saying, I don't know if I want to, take a chance at answering that question. What if I get it wrong? That's going to be so embarrassing, right? You've been there, right? You've seen that. Okay. All right. So here we're simply asking, all right, well, how much does a social stressor like potential embarrassment reduce the risk of, or, reduce a person's chances of taking a chance, really, and answering a question, a difficult question. Okay. All right. All right. So we're going to be working with two variables. All right. So social stress, and I should have indicated social stress is our independent variable. Okay. This is our independent variable. So remember, in a two-sample t-test, the independent variable can only have two values. Okay. It can only have two values. Okay. So we need to set up a variable, along those lines with two values. Okay. So social stress has two values. All right. So here, the first value, the person has not been exposed to a stressful social environment. Or two, the person has been exposed to a stressful social environment. Okay. All right. And then risky behavior refers to the number of times a student answered a difficult question in a classroom setting. Okay. All right. So again, the risk is taking the chance to answer a question that you might get wrong. Okay. You might get the answer wrong. But moving on. All right, so I know there's a whole lot going on in this graphic. All right, we're going to spend a few minutes on this. All right, but this is essentially the layout, the schematic, if you will, for the experiment that we're conducting, for this hypothetical experiment. Okay, this simulated experiment. All right, so we start right here. All right, so we have this, let's suppose that we already have this sample of students. All right, and once we get that sample of students, what we're going to do, we're going to randomly assign them to either group A or group B. Okay, and so we're randomly assigning them to the group that's going to be exposed to some sort of social stress, and randomly assigning them to a group, or randomly assigning them to a group that won't be exposed to some source of social stress. Okay. All right. So randomization, just like we talked about in classes several weeks ago, right? Just like we talked about then. All right. Randomization reduces bias, right, in what we see. In this case, it reduces any sort of bias that might lead people who are more sensitive to social stress into one group versus people who are less sensitive, who are biologically, genetically less sensitive to social stress in another group. All right, we're going to make sure we have randomization is going to make sure we have a pretty good mix of both of those types of people in each group. Okay. All right. All right. So now, in order to carry out the comparison, all right, we're going to assign, we're going to create 4 different samples, essentially. Okay. All right. So for group A, our first sample is going to come at this point, right? The number of responses to questions, right? The number of times they responded to questions in a classroom setting, all right? So this is going to be our first group right here, okay? Our second group is going to be here, all right? This is group B. Group A has not been exposed to the social stress yet. Group B obviously will not be exposed to the social stress yet. All right, so these two groups, are pretty much the same. All right, they haven't been exposed to anything yet, so everybody sort of starts out looking exactly the same. All right, so they should be the same. Whatever the number of responses here, whatever the mean number of responses here to questions would be in this group, all right, we should see a very similar number here, all right? All right, because again, we've taken the sample of people, okay, and we have randomly assigned them to these conditions, okay? All right, so if we've done the random assignment correctly, what we should see is that when we ask these people in a classroom setting some difficult questions, all right, and then we want to count the number of times these folks responded to the questions, okay, they should look a whole lot like this group here, okay? All right, that's if we've done the random assignment correctly. And of course, since this is a simulation, of course we're going to do it correctly. And of course, these two groups are going to come out looking pretty much the same. All right, but one of the things I wanted to emphasize as I was putting all this stuff together, one of the things I wanted to emphasize is that, again, this is a simulation. All right. You will not get data this clean and this neat that you're going to see here in an actual experiment, okay? In an actual experiment, things are going to be a little messier, right? But anyway, so for group A, right, we're going to, take some measure of the number of questions, a number of difficult questions they try to answer, all right, at time 1. All right, they're going to be exposed to some sort of social stress, okay? And, if you look at the literature in social psychology, social psychologists have come up with a number of different ways to expose people to, social stress, okay? One way, for example, is called the Trier, I think I'm pronouncing that correct, the Trier social stress test. Okay, in which you tell someone if you want to put them under some sort of stress, you pull them aside and you say, all right, well, we're going to want you to give a speech about the worst thing you've ever done in your life. Okay, and you're going to have maybe 10 minutes to put that speech together before you give it to a class. Okay, all right, so you can imagine somebody being put in that sort of situation, being expected to do that sort of thing, they might start sweating a little bit, right? Okay, but anyway, so we're going to, let's say that we've come up with some method of exposing them to some sort of social stress, and then we're going to put them in the classroom again, and then we're going to ask them, some, very difficult questions that we're going to see, all right? How many are going to respond? All right, how many times are they going to respond? Okay, so what we're thinking this is going to happen, okay, and according to our hypothesis, what we think is going to happen is that the people exposed to social stress, right, if they answer, let's say 10 difficult questions here on average, that average might drop to half of that, okay? Right? Because now they have this stress weighing on their mind, they're going to be much less willing to take a chance, right? At answering a difficult question and maybe risking even more embarrassment, in the eyes of their peers. Okay. All right. So then what's going to happen to these folks? All right. So for group B, again, this group is not going to be exposed to any sort of stress. All right. So the number of questions that they, try to answer at time 1 is probably going to look much the same as in time 2. Okay. All right. Because again, they're not being exposed to any sort of stressor. Okay. So there should be no other reason why, you know, uh, you know, the number of questions they ask or they try to answer at time 2 is going to be different from, the number of questions they try to answer at time 1. Okay. All right. So to make it a little bit easier, all right, the 3 comparisons, we're talking about the comparisons here. So there are going to be 3 comparisons, and to make it a little bit easier for you to kind of track what comparisons are being made, okay, I've highlighted, I've put a dotted green line here that connects the groups we're going to compare. All right, so the first comparison is going to be between our first group here, A1. So this is group A at time 1. All right, and group B at time 1. So group A1 is going to be compared to group B1 first. That's going to be our first comparison. And again, we're thinking, all right, well, since group A1 has not been exposed to any sort of stress yet, all right, these folks should look pretty much the same. All right. The second comparison is going to be between group A1, so the group of folks at A1, and then that same group of folks at A2. So group 1 at time 1 and group A at time 1 and then group A at time 2. All right, we're going to make that comparison. That's going to be our second comparison. Okay. All right, and then our third comparison and our final comparison is going to be here between group A at time 2 and group B at time 2. So again, if the hypothesis is correct, right? If our hypothesis is correct that social stress is going to reduce, any sort of risk-taking behavior, all right, then we should see a couple of things, right? The number of questions that students try to ask, that our simulated students try to ask at time 2 should be lower, right? Because after the stress, after exposure to the stress, right, they should be far less willing to try to answer difficult questions here than at time 1, okay? Also, this group should be far less willing, after exposure to social stress, they should be far less willing to try to answer difficult questions, all right, than what we observe in group B at time 2, all right? All right, so we need to set up these 4 conditions, all right? So we're going to call one condition A1, A2, and then B1 and B2, okay? So keep that in mind when we start putting together the SAS data, the simulated data. Let's see what else. Okay, so here's just sort of another way to kind of lay out what we're going to do with this experiment, okay? All right, so again, we're going to make 3 comparisons, or we're going to conduct 3 t-tests, all right? 2 sample t-tests, 3 2-sample t-tests. Okay, so the first comparison, or the first t-test, we're going to compare group A1, so that's group A at time 1, to group B at time 1. Okay, so group A and group B will answer the same number of questions on average. Okay, on average. Okay. All right. Now, what does that mean for our HO? Do we hope to reject HO, or do we hope to not reject HO? Okay. All right. So in this first case, again, if randomization works, for that first comparison, these groups should look pretty much the same. All right. So in this case, we're hoping not to reject HO. So like I said, I think in the lectures for chapter 9, or maybe even in chapter 8, sometimes you don't always want to see HO rejected. In a lot of cases you do, right? But not all the time. All right. So here's one of the cases where we hope that HO will not be rejected, that the null will not be rejected here. Okay, because that would mean that this hypothesis is correct, right? Group A and Group B at time 1 look exactly alike, all right? Or they are very similar to each other, okay? All right, and so the type of t-test this is an independent samples t-test, okay? All right. The second test, we're comparing Group A at time 1 to Group A at time 2, okay? All right, so we're saying here for the hypothesis that Group A at time 2 will answer fewer questions than at time 1 on average, okay? All right, so again, at A2, Group A at time 2, all right, this is after exposure to the social stressor. Okay. All right. So the number of questions they try to answer at time 2 should be fewer than the number of questions they try to answer at time 1. And again, on average, there should be an average difference there. Okay. All right. So do we want to reject HO here? Yeah, in this case, we're hoping to reject HO because, again, if we reject HO, that says, well, our hypothesis is probably correct, right? We can't say, absolutely it's correct, right? But it's probably correct. So it does seem that, social stress can drive down risk-taking behavior, okay? At least in the context of answering questions in class, okay? All right. So we're hoping, to find that the groups are different and then also rejecting HO, okay? All right, now the type of t-test this is a paired samples t-test, all right? So the first test is an independent samples t-test. The third test is also an independent samples t-test. All right, so you're going to see that these two, the SAS programming for these two types of, for the independent samples t-test, right, is going to be quite a bit different from the paired samples t-test, okay? All right, so when you get to this part in the gear project, all you have to do is just kind of follow my lead, all right? Just take a look at how I set it up, and you can set up yours the exact same way. And again, if you want to look at, a different independent variable, a different dependent variable, please have at it. Take the shot, okay? Just try it, okay? All right, let's see. All right, so that's the paired samples t-test for the second test. And then our final test here, okay, we're going to compare group A2, so group A at time 2, to group B at time 2. All right, and here's what we're hypothesizing. Group A at time 2 will answer fewer questions than group B at time 2 on average, okay? Because again, group A has been exposed to the stressor. Therefore, we would expect them to ask or to answer fewer questions, okay, than group B at time 2, okay? And again, here we're hoping that we reject the null, okay, because that will indicate that, yes, the two groups are different. So remember, in a two-sample t-test, the null hypothesis always states the groups are the same. All right. So here, back in the first test, we're hoping to come to the conclusion that yes, the groups are the same. Okay, because they haven't been exposed to any stressor yet. Okay, right? But after that, in the second test and in our third test, we're hoping to see a difference between the groups. Okay, because in both of these conditions, right, group A has been, this comes after group A has been exposed to the stressor. Okay. All right. So again, now this you don't have to do this in yours, but again, you can set up a table like this, and set it up exactly as I have it here, and it's a nice device, for the researcher, right? Because it helps you kind of clear up your thinking about what sort of comparisons you need to make. What sort of hypotheses are being, tested in these comparisons? What sort of decision do you hope to make about the null hypothesis? Okay, and then just kind of reminding yourself of what sort of test you need to run for these different conditions. Okay. All right, so we get to the SAS programming set. Okay. All right, so remember what I told you at the beginning when we were talking about key terms and I pointed to nested do loops. All right, so you're looking at a nested do loop right here. All right, so you recognize, the first two lines, right? We've written those lines, many times, right? In, labs and gear projects, okay? So here I just set up, data, stress, okay? And again, it could have been something else, but data, stress, and call stream init, since we're, asking to use SAS's random number generator, 1949. Again, that's a number that, is meaningful in the context of the university here. It was founded in 1949, but you can use whatever number you want. All right. And then the nested do loop is exactly as it sounds, okay? So it's one do loop nested inside of another, okay? All right, so we can say, we're trying to put a one do loop inside of a house, okay, or something like that. Okay, so this first do loop that we write here, okay, this sort of forms the basic structure, okay? This is the bigger do loop, okay? And the second do loop that we set up here is the smaller one, all right? So we're going to put this smaller one into the bigger one. All right, so what will happen here when we say do group, right, equal 1 to 4, we're essentially telling SAS, all right, we want you to set up a grouping variable with 4 values, 1, 2, 3, and 4, okay? All right, and then what we say here, right, we're essentially telling SAS, all right, for each group, we want you to set up 50 observations, okay? So that way we want to make sure that each group has the same number of observations, okay? All right. So then we tell it we give it some more information here. We say if group equals 1, all right, then answered 1 looks like this. It's going to have this distribution, okay? All right, so answered 1 is the number of questions the group answered, right? At time 1, okay? All right, so then if group equals 2, then answer 2 has this distribution. Okay, so this is group 1, as you'll see in just a minute when we get to the formatting statement. Group 1, group equals 1, that's going to represent group A at time 1. Group 2 is going to represent group A at time 2. So notice the difference in the means here. All right. So group A at time 1 answered, the average number of questions that folks in the class tried to answer was 14. Okay, that was the average number. All right, so you had a lot of folks you had some folks asking, 15 or answering 15 or 16 questions, all right, and then some folks asking, answering fewer than that. Okay. All right, but then let's look. All right, this is after the stressor. Okay, so this is so group equals 2. This refers to group A at time 2. All right, so the number of questions answered at time 2 for this group, right? It has a mean of 8, the standard deviation of 1. All right, so there, again, a lot of folks were asking, answering at least 14 questions, right? In the first condition, all right? So group A, in the first condition, we had, on average, we had about 14 people trying to answer, or we had 14 questions that were attempted, okay, by folks in the class. All right. But then after the stressor, okay, that average dropped down to 8. Okay, so it dropped quite a bit. All right. So we're hoping that this is the result of the exposure to the stressor. Okay, because that would sort of confirm our hypothesis that, yeah, exposure to stress does drive down, risk taking. Okay. All right. And then for group 3, group equals 3, this would be group B at time 1. And again, you'll see this in just a few minutes. Okay. So, and again, they look, pretty much like group A at time 1. Okay. All right. Group equal 4 represents group B at time 2, right? So that's why we have answered 2, right? The number of questions answered at time 2. All right. And again, since group B, the folks in group B have not been exposed to a stressor, right? The number of questions they answered at time 2 looks a lot like time 1. Okay. All right, so then we have the output end and end. Now the reason why we have end twice here is because we have 2 do statements, right? And so for each do statement we need an end statement. So we have do group equal 1 to 4, and so we need to tell SAS to end that one. Do in, so sample size essentially, equal 1 to 50. All right, we need to say end there. All right, let's move on. All right, so we want to set up labels next. So we're still in the data step. All right, so label group, and so we'll say experimental group answered 1, number of questions answered at time 1. Answered 2, number of questions answered at time 2. All right. And then here is when we get into the procedures. All right. So we have our proc format statement. All right. So we want to set up a format called GF, so group format. All right. So if for a value of 1, we want SAS to label that group A1. Okay. All right. So again, thinking about what we saw in the schematic for the experiment, right? A1 is group A at time 1, all right? For a value of 2, right? That should be labeled as A2, all right? So this is group A at time 2. Group B at time 1 is going to be associated with a value of 3. And then group B at time 2 is going to be associated with a value of 4 for this format. Okay? All right. So when we get into these t-tests, all right, so this is our first test. Okay? And so, just to kind of remind you of what we're doing here, I included a title, right? So title, test 1. And we're looking at the mean difference between group A at time 1 and group B at time 1. All right, and again, we're expecting that these folks are going to look pretty much the same. All right, now, this where statement here, this is something you haven't, I don't think I've used this before in the labs, okay, or in the gear projects. All right, but it's a really simple thing. All right, now remember, I told you that in the lecture for Chapter 9, I told you that when you set up a 2-sample t-test, all right, you can only have 2 samples included, all right? Right? But now, remember what we did a couple of slides ago, right? We set up a group variable that has 4 values, but our group variable can only have 2 values, okay? So what we do is this. We tell SAS, okay, when you run this t-test, the only groups we want you to look at are groups groups number 1 and group number 3, okay? Group 1 and group 3, all right? And that corresponds to group A at time 1, and then group B at time 1, which is 3, okay? So SAS is only going to look at those 2 groups. And so when it sees this reference here, it's not going to, try to use all 4 values. It's not going to try to look at all 4 groups. It's only going to look at the groups that we told it to look at right here. Okay? So where group in 1 and 3. Okay? All right, semicolon, class group. All right, so here's where we're telling SAS, all right, so group is the independent variable. All right, and here's where we tell it the dependent variable. So var answered 1, semicolon. All right, and then to help us, kind of interpret what we're seeing in some of the output, we want SAS to use a format, the format that we created, GF, for the variable group. Okay. All right. Now you don't see the. I give you some of the output here. All right. So it doesn't show all of it. All right. But the reason why I'm showing you this here is because I want you to keep in mind that even though SAS is going to kick out quite a bit of information at you, there are only a few pieces of information you actually need. All right. Okay. And they're all right here in this table. Okay, and you'll see this in your output. You'll see a table like this in your output. Okay, all right. Now, as we talked about in the lecture for Chapter 9, which one do you use? Okay, which row do you use? Well, that sort of depends upon what you see down here. Okay, all right. So if the variances are the same, okay, so again, if this number, if we look down here at the equality of variances table, all right, and if PR of F is 0.05 or less, all right, then we have to use the variances unequal row, okay? All right. But if the variant, but if the PR of F is greater than 0.5, which is, it far exceeds 0.05 here, right? So if PR of F is greater than 0.05, okay, which it is here, then we use the top row, right? Equal variances, all right? Because this is saying here, so if PR of F is 0.05 or less, that means we have to reject the null. And the null says that the two groups are the same. They have the same variances, okay? So if it's 0.05 or less, then there's only a very small probability of the null being true, okay? If it's above 0.5, we say, all right, the null is probably true, right? And so the variances are probably equal. If it's not true, they're unequal, okay? All right, so right here, we see a value that's far larger than 0.05, all right? So we would say here that, all right, well, the variances are equal. So we look here at the pooled method, all right? Variances are equal. DF is 98. T-value is 0.49, all right? And again, we have a PR of T of 0.6287. All right, so just like with any other probability that's associated with a test result, a test outcome, if the probability of the outcome is 0.05 or less, all right, we reject the null, okay? So in this case, we have a probability that far exceeds 0.05, right? So in this case, we say, well, the null is probably true. Okay. So the null says, again, that the two groups are the same, right? So if the probability was 0.05 or less, that would say that there's only a very small probability of the null being true. All right, so if it's 0.05 or less, we reject the null. And so then we would say, all right, well, the two groups, are very different in their means. Okay. But here we have a value for the probability that far exceeds 0.05, right? So here we conclude, all right, well, the null is probably true, so it's probably true that these two groups are exactly the same in terms of their means, okay? All right, let's go. So we're going to see more like this over the next few slides. All right, so for our second test, and again, just to help you out here, right, I included the title, Test 2, paired mean difference between A1 and A2. All right, so here's a paired samples t-test, okay, right? And so we're looking at the difference in means in the number of questions answered, okay, between group A at time 1, and then after the social stressor, after exposure to the social stressor, sorry about that, group A at time 2, all right? So this is a what we call a within group comparison, okay? All right, so let's look at how to set it up. So again, it's quite a bit different, all right? In terms of setting it up for a t-test procedure, right? It's quite a bit different from the independent samples setup, okay? All right, but still here. All right, so we have where group in 1 and 2. So again, we're telling SAS, we only want you to look at these two groups, okay? We only want you to look at these two groups. So group A at time 1, before the social stressor, and then group A at time 2, after the social stressor, okay? So we only want SAS to look at group 1 and group 2, all right, and make that comparison. All right. So then we tell SAS this is a paired uh, or within group test of mean differences. Okay. So we want it to look at A at time 1, group A at time 1, and then group A at time 2. All right. And then we tell SAS again, use this format for group, okay, to distinguish between the groups here. Okay, so this is pretty much all of the output that SAS generates from a paired samples t-test. Okay, so it's a lot less than what you're going to see for the independent samples t-test. But again, even here, you just need a little bit of information here. You just need to look at this last table down here at the bottom. All right, so DF 49, the t-value is 57.55, and the PR of t is something pretty close to 0. Okay, so what do we see here? So this is saying that the null hypothesis, which states the two groups are the same. So the null hypothesis in this case would say that group A at time 1 looks exactly like group A at time 2, right? The two groups are the same. This is saying that the probability of the null hypothesis being true, of that statement being true, is something very close to 0. Okay? So then in this case, we want to say that, well, we can probably reject the null hypothesis. We can probably say, it's probably not true. Okay, it's probably not true. All right, so we can reject it. And so we can conclude, all right, well, based on what we see, these two groups are very different in their means. One group before the social stress test, or before the social stressor, right? And then the second mean coming after the social stressor. All right. So remember, the mean for group A2, right? For group A at time 2, right, was much lower, right? The number of questions they attempted to answer much lower than the number of questions they attempted to answer at time 1. Okay. All right. So this is the third and final test. All right. So here we're looking at, we're looking at another independent samples t-test, right? So the title, test 3, mean difference between A2 and B2. So group A at time 2 and group B at time 2. We're comparing those two groups. So here we tell SAS that we want it to focus only on those two groups, right? So compare group equal 2 and group equal 4, all right? So class group, again, telling it this is our categorical variable, this is our independent variable, and then our dependent variable in this case is answer 2, okay? So we're comparing these two groups based on the number of questions they tried to answer at time 2. So again, what we're expecting to see in terms of our hypothesis, group A2 should have a mean that's lower than group B2. Okay. All right. So once again, we take a look at the top table here. Once again, according to our equality of variances test, right, we can look at the pooled, right? Because again, if this is 0.05 or less, we look at the Satterthwaite or the unequal variances, all right? But it's far larger than 0.05, which means we can treat the two groups as having equal variances, and so we can take a look at the pooled. Okay, so we have DF of 98, a t-value of negative 35.75, and that negative tells you that A2 Group A at time 2 has a lower mean than Group B at time 2. All right, and that there's a very, very small probability that the null hypothesis, which states the two groups are the same, is true. Okay? All right. So let's see. Let's just got just a couple for the results slide. Okay. You're only writing out 3, quick, brief statements, just like you see here. All right. If you want, you can just copy the text exactly as it is here. If you try a different setup, or if you have different labels for your groups, you can still use most of the text, just replace as necessary. Okay. And then if you get different numbers, again, just keep the same structure, right? So you're looking at the same basic format. This is the APA format for reporting t-test results. You want to keep the same thing, but if you get different numbers, just insert the numbers as necessary. Okay. All right. So let's take a look at what we have here. All right. So for test 1, again, we're looking at Group A at time 1, and then Group B at time 1. All right. We came to this conclusion: the mean number of questions answered by Group A at time 1 was not significantly different from the mean number of questions answered by Group B at time 1. And then these are the numbers I pulled right from the tables I just showed you in the previous slides. Okay, right? T is the type of test we're running. So we're running a t-test with 98 degrees of freedom. All right, and the value of t is 0.49, and the corresponding p-value is 0.63. So here we failed to reject the null. The null states again that Group A at time 1 is going to be the same as Group B at time 1. That's what we see. We accept that the null as probably true. Okay. Right. And so and again, you don't need to say much more than this. Okay. Just get right to the point, because that's what people want to see when they're reading these studies. Just get to the point. Okay. All right. So for test 2, right, the mean, again, here's where we're comparing Group A at time 1 to Group A at time 2. Okay. And again, we expect that Group A at time 2 is going to have a lower mean than Group A at time 1. So here we say the mean number of questions answered by Group A was significantly lower at time 2 compared to time 1. And again, we give the results of the paired samples t-test. T, 49 degrees of freedom, 57.55, right? And the null has a very small probability of being true, so we reject it and say, yep, there's probably a difference. There's probably a real difference between Group A at time 1 and Group A at time 2. Okay. Then test 3, all right? The mean number of questions answered by Group A was significantly lower than the mean number of questions answered by Group B at time 2. All right, so both groups are at time 2. All right, for Group A at time 2, this is after exposure to the stressor. Okay, so their mean number of questions dropped. Okay, and it dropped lower than what we saw for Group B at time 2. All right. So again, we use the APA format to report the results. And again, just thinking about this, different disciplines. So, different majors will have different formats they want to see. All right. So make sure you become familiar with the formats of your major. All right. For reporting results of analyses. All right. So the we're using t-test, 98 degrees of freedom, right? The value of t is negative 35.75, okay? And again, once again, the null hypothesis, according to these numbers, the null hypothesis has a very small probability of being true, okay? All right. And then for the interpretation, all right, very quickly. Results of the experiment suggest students who are exposed to social stress take much fewer chances. I don't know if I like the way I wrote that, but you know what I mean. They take fewer chances. I guess I could have just said fewer chances. They take fewer chances to answer difficult questions in class. Okay. End of story. All right. So that's the big exit right there. All right. And again, folks, yeah, I mean, you really do want to get in the habit of, being right to the point, man. Just get to the freaking point. Okay? Don't beat around the bush. All right, folks, I think that is it. Yep, that's it. Okay. Thank you so much for signing up for the class. Now, I have here, contact me if you need help on this assignment and on any of the other assignments you still might need to do. All right. But let me extend this offer a little further. All right. So if you take another stats course, okay, or another research methods course, or a research methods course, all right, and you need some help with running the statistical analyses or what have you, I'll help you. All right, and it doesn't have to be in my department. I'm over in sociology, but if you're like over in, I don't know, health sciences or something like that, I mean, you don't have to be in the same department. Just say, hey, Dr. Davis, help me out, okay? And I'll help you out. All right? No problem at all. All right, well, that's it for the semester. So once you get this turned in, you're done. Go have a wonderful holiday season, okay? All right. Take care.